Okay, good morning, ladies and gentlemen. As promised, here is our modeled example of performing linear regression using a least squares regression line. For our scenario, we have a random sample of 16 used Ford F-150s selected from a for sale list on autotrader.com. The number of miles driven, and the sale price are shown in the data. Our first task is to construct and describe a scatter plot. So our miles driven has become our explanatory variable and will be graphed on the x-axis. Miles driven, please note that it is scaled to the 10,000 miles. And price, our response variable, on the y-axis, and it is scaled to the thousands of dollars. Okay, let's go ahead and construct our scatter plot. We are going to go over to use our calculator. So here we have the emulator, and I've gone ahead and I've loaded the miles driven as my list here. I called miles, and I've loaded in the price under the list price. Okay, so we'll come over to our scatter plot. We will use the graph, so select the scatter plot. So we have here our x value is miles, our y value is price. I'm going to zoom and we're going to use fit, and here's our scatter plot. So now we're going to take some time to transfer this briefly to our graph. So here we have our scatter plot. So to describe it, remember in describing it we have describe strength, form, direction, and outliers. So in terms of strength, we see that here they seem to be clustered somewhat together, so I'm confident in saying that this is a pretty strong association. Remember, we can't use correlation here yet because we have not proven that. So we're going to have strong association. It is linear. This is definitely forming a pattern of a line heading down the graph from left to right. Direction, it is going down when we go left, so that would make it a negative. And I'm not seeing anything outliers. Everything seems to be right along the axis of the direction, so there are no outliers. There, ladies and gentlemen, is task 1. Task A, we've constructed and scattered scatter plots. Let's move on. B says to calculate the correlation coefficient, but we first need to check, remember we have to check the conditions. So going back to our scatter plot, let's check that. Here's our scatter plot. First condition we need to check is a quantitative data. Price, definitely numeric, definitely measuring something. Miles driven, again numeric, and measuring distance. So we have one variable measuring a value, one variable measuring distance, so it is in fact quantitative. So the data is definitely quantitative. Straight enough, we did agree that it was linear. And we can see that it is definitely linear. So linear. And as we said before, there are no outliers. So this graph definitely does meet our conditions to be a correlation coefficient. So to go ahead and calculate the correlation coefficient, we'll again go to our calculator, returning to the calculator side. And now we are going to go to our menu, statistics, calculations, and we're going to call it linear regression. Remember, we want A plus BX because this is A plus BX. List 1 is miles. List 2 is price. we can go ahead and OK. And we have an R of negative 0.816. So our R value is negative 0.816. Okay, so that definitely is supporting that it is a negative knowing that value, it is supporting that we have a strong negative correlation between miles driven and price. Okay, so moving on. Next task here is to construct the equation of the least squares least squares regression line, and I apparently spelled it wrong. It should be LSR. So again, we can go back to our calculator. The nice thing about the equation that we did, we are given our A, and we are given our B. A is B naught, and B is B1. So that means price is our Y variable, so price is predicted, so we'll include the hat. Our B naught is 36,981.9, 36,918.9 plus our B. Our B1 is negative, so we can write minus 0.1523 X. Or actually, it's not X. It's going to be miles. So that, ladies and gentlemen, will be the equation of our least squares regression line. So we come back here and sketch that. That's saying 36. And sketch it in green right there. So we look at here how to sketch this. I'm going to go back and use our scatter plot just to get an idea of what that's supposed to look like. We can come back here, we can go to graph entry, we can do our function. And because we saved it under F4, here it is right here. We go ahead and turn on F4. Let me turn it on. Oh, there we go. And so we can see the line, roughly how it's going to sketch. So we're going to come back here, and I'm going to sketch that. And that, ladies and gentlemen, is our sketch line. I'm going to go ahead. Make it look like a little bit more like a line. That was not a good line. And there's our line. Okay, so now let's look at our next task. So here we're going to interpret the slope of our regression line. Remember, this is our B. Oops. Turn the pen back on. This is our B naught. and this is our B1. So we're going to interpret B1, which is our slope, is negative 0.1523. Remember, that is units of y, so that would be dollars, over units of x, which is miles. So we have a slope of negative $0.1523 per mile. So that means for every mile driven, the price of the truck can be predicted decreases $0.1523 or approximately 15 cents. Okay. So now if we look at B naught, our B naught is 36,918.9, which is in our units of y, so that's in dollars. So for 0 miles driven, because B naught occurs when our variable miles is 0. So for 0 miles driven, the price of the truck is $36,918. Now remember, we need to check to see if that is significant. So let's go back and check if it is. Now it does make sense that the truck would be $36,000 because you could buy a truck with 0 miles driven. That's like buying a truck off the lot, brand new truck. But we need to make sure it's not an extrapolation. So we look at our range. It looks like our minimum value is 4,000 miles, and our maximum is 144,000. So 0 is outside that range. So, though it makes sense, in context, it's suspect because it isn't. It is an extrapolation. Okay, so there, ladies and gentlemen, we've interpreted the slope and we've interpreted the y-intercept of our regression line. Now continuing on, here we're asked to calculate the predicted value of a truck with 100,000 miles. So we are able to use our regression line. So let's switch over to our calculator again. Switching back to our calculator, we know we stored the equation is stored under F4. So to make that substitution, I'm going to go ahead and call F4. And I'm going to call it, let's call function F4. And we're going to call it for 100,000. And that gives us a value of $21,679.60. That's using our equation, if you remember. So we can type, if I type F4 here, it didn't work. So called our F variables, so we can come back here and we know that our y, oops, sorry. our price predicted be 21,679.6. So the predicted price of a truck $100,000, I'm going to use K for that, miles, is $21,679.60. Now we can go ahead and do the same thing for the 200,000. And we can use our calculator this time, again calling the function F4 for 200,000. And it will return a value of 6,440. It would return a value of 604. But remember, our max, if you recall, our max was only 144,000. So our max was the max was 144,000 miles. So the 200,000 is outside the range of the model. Which makes it then, it is an extrapolation. And as an extrapolation, the value is suspect. Okay there, so ladies and gentlemen, we've now calculated the predicted value. One we were able to do for 100,000 miles. It was within our range. 200,000 miles was outside of our range, so it was suspect. Now, as we talked yesterday, there's conditions that make whether or not that model is even an appropriate model. So we are going to have to sketch the residuals plot. And again, we are going to our calculators to do that. Okay, here we've come back to our calculator, and we're going to find that we need to find our predicted values. So again, I'm calling the function F4, but as my argument this time, I'm going to call the entire list miles, and I'm going to store that as predict. So now here is the list of our predicted values that correspond with each of the x values. Now to find the residuals, we're going to take price, which had our actual y's, minus predict, which has our predicted y's, and I'm going to store that as residuals. So here we have our list of residuals. Now to create the residual plot, we're going to go back to our graph, go to menu, we'll call it scatter plot again. Now for this one, we are going to put in our residuals. For this one, I'm going to put in our miles, because that's the way I drew the plot. Now, I have to make sure I turn off our original scatter plot. I'm just going to have to turn off our functions. And here's our residual plot, which we are going to graph onto our. So here we have our residual plot. And based on this residual plot, it does not look like there's any pattern to this. They're pretty randomly scattered. So yeah, so the LS, LR is appropriate. As the residual plot shows no pattern. Okay, moving on. For K, task K, we're going to calculate and interpret the standard deviations of the residuals. Thankfully, we have those stored, so we're going back to our calculator, back to the calculator version. But this time, when we go into menu and we select statistics, we are going to choose one variable statistics. The numbered list is 1. So our actual list we're going to pick this time is the residuals. And there we have our. So we are going to go ahead with SX because this is a sample. So we get 5,245.18. So S residuals is 5,245.18. That is in dollars, which is telling us that the average or the typical error in our predicted values is approximately $5,245, which is not bad over the range that we're having. So now, our last task here is to calculate and interpret R2. Going back to our calculator, if we go up, to original calculations, we are given the R-squared value of 0.666505. So R-squared is 0.666, or approximately 66.6%. And as we've discussed, that this interpretation is the variability of the price of the truck wait a minute. Telling us that according to our model, according to this model, 66.6% of the prices variability or variance is due to the variance of the miles driven. And there, ladies and gentlemen, is a model of doing linear regression, doing all the different parts. Apologize for the length of this video. However, do use this video, review it if necessary before tackling the assigned practice exercises. And I will see you in class tomorrow. Thank you.